Hi guys, Mr. Bennett here again. Now today we're going to be looking at our last question. I'll probably do a video on, and that's question 16. Now in this one again it's a little bit different, and that's why I want to show you this one in particular. So in this particular case we have a cricket example where a bowler is bowling the ball from a height of 2.4 metres. So that's the height there. I've sort of tried to draw a diagram of what it might look like. And the angle that the bowler is releasing the ball is 6 degrees below the horizontal. Now the velocity of the ball is 144 kilometres an hour. So divide that by 3.6 and you get 40 metres per second. Alright, so obviously the first question in that, if we're just looking at question, it's number 16, isn't it? Alright, so how far down the pitch is the ball going to land? Now again, it's one of those things, it doesn't ask you to find the initial horizontal and vertical velocities, but you can't do this question without actually finding them. So again, you'll need to just draw your triangle. V cos 6 is going to give you a horizontal velocity. V sine 6 is going to give you a vertical velocity. Now remember here, it's really important that you actually remember that's negative 4.2 meters per second. Alright? So to work out the obviously time of flight, again we have to work that out to actually know how long it's going to take to hit the ground. So that's going to be negative 2.4. We know the vertical velocity is negative 4.2, and that's going to be negative 4.9, half of gravity. So rearranging that, that becomes now plus. Alright, put that into your graphics calculator, and that will work out to be 0.39 seconds. Now, because you know the horizontal velocity, right, is equal to 39.8, which we worked out originally, times by the time of flight, we know that that ball's going to hit the ground 15.5 metres down the pitch. Now, because the pitch is about 20 metres long, that's probably pretty good. Probably going to be a pretty good length. Alright, so that's the first part of that question. Right, the next part is to work out how fast it's going to hit the pitch. Alright, so obviously it's going to pick up its vertical velocity, so it's starting with the vertical velocity of negative 4.9. It's going to be moving downwards with gravity for 0.39 of a second, so its final vertical velocity is going to be negative 8 meters per second. So again we have to use Pythagoras to work out its speed. Alright, so if it's asking only for speed, you don't need to do the angle. So that's what its speed's going to be, is 40.6 meters per second. Now, when we're looking for kinetic energy, for the third part of that question, it's asking you to say if the bouncing ball loses 20% of its kinetic energy, find the speed at which the ball reaches and meets the batsman. Okay, so what we need to look at is obviously 100% of the kinetic energy would be the velocity it's got. So we know the final kinetic energy is only going to be 80% of that. Alright, so it's going to be only 80% of the velocity. So if we know the kinetic energy is equal to, have I done that calculation over here? I think I did. Right, so we just did the rearrangement. So we know Kant is half mv squared, and the mass of the ball is not given to us, and that's not really all that important. We know that the velocity is equal to the square root of the kinetic energy. Alright, so then obviously we know it's going to be square root of that particular thing over here. So that gives us an answer of 36.3 meters per second. So it's a little bit different, the sort of question that you might get. Hope this helps, and just make sure that you work through the rest of the questions. You need plenty of practice at problem solving with these.